So, good afternoon to everyone. Are you ready for today's laboratory exercise? Uh, our lab this afternoon will keep you on your toes. Okay? Because you will not be sitting there for as much as 3 hours or less than 3 hours looking at the microscope. You will be performing a series of laboratory examination. But very common laboratory examination. Okay? So the complete blood count is a routine test requested frequently by us physicians in order to help us arrive at a accurate and a precise diagnosis. Okay. So for this afternoon's activity, this will entail the following task. Describe the method to obtain blood by finger puncture. Describe the methods of estimation of hematocrit and hemoglobin. Third, describe the normal value and make an interpretation of the result that you obtain from the exercise. Then perform the steps in doing the manual RBC counts. Okay. So, for today's activity, your subject will be your groupmate. Okay? So you have to choose someone in the group that will be the one who will provide the blood sample. Okay? That's why I requested the class to have a full lunch and probably not full lunch and also carry with you clean gloves. Okay? Because blood is considered as a biohazardous substance. Okay. And then for some, this will serve as a review for those who have a background in laboratory medicine. But I think with the majority, this will be your first encounter. Okay? But finger puncture is the initial step in the section of hematology because it is the process in how we obtain a sufficient blood sample. So, let's start with blood extraction or blood collection. There are two methods of collecting blood. It can be through the venous route or through the capillary method. The capillary method is the one that we're going to perform this afternoon. The capillary method, the site of this method is in your fingertips. Okay? And the tool that we're going to utilize to accomplish this blood extraction or blood collection is the blood lancets. Okay? I don't think we... yes. This one. This is an example of the disposable blood lancets. Okay? So you have to remove this circular cap, okay, to expose its sharp pointed tip. The sharp pointed tip is used to pierce the skin of the finger. So, in the capillary method, find a spot on a fingertip in your hand, okay? And it should not be callous. So, among the 5 fingers on your hand, either right or left, it is the third and the fourth fingers deemed to be preferred, deemed to be preferable to obtain the blood sample because it is less callous. Use the side if possible because it is less sensitive. So the ideal site to pierce the third or fourth finger, it should be on the side. Okay? It should be somewhat at the side of the central portion of your finger. Okay. Clean the site before, after selecting the the area where you're going to pierce, where you're going to pierce the tip of the lancet, of course, you have to disinfect the site to avoid possible contamination and infection. So we're going to utilize an alcohol-soaked cotton swab or cotton ball. Okay? The alcohol may either be ethanol or ethyl alcohol or the isopropyl alcohol. And then, after disinfecting the site with the alcohol-soaked cotton, let that site dry first, or get another dry cotton and wipe the area. What could be the reason why you have to let the area dry or wipe the moistened area of the skin where you're going to extract blood? It's because the spherical form of the blood won't be obtained or won't be accomplished if the area is moist. Okay? The blood drop should have a rounded or spherical shape in order for it to easily enter the pore of the capillary tube. Okay? That's very important. So you have to allow the site to dry. Okay? And then prick the finger in a quick, rapid motion. Okay? In a quick, rapid motion. And then after piercing the surface of the skin, of course, naturally, there will be blood that will ooze out of the site. Do not include it in the blood collection. Okay? The first drop of blood that will seep out of the wound is contaminated with tissue fluid. Now, this tissue fluid should not be included because it contains fluid from the interstitial spaces, and also it may contain clotting factors. And we do not want that the blood, after it enters the interior of the capillary tube, to clot. That's why you have to discard the first drop of blood with a piece of cotton, and then it's only the succeeding blood drops that will be included in the blood collection process. Okay? When the patient is an infant under 6 months, the site of blood extraction using the capillary method is the heel or the big toe. Okay? If the infant is older than 6 months but small, the heel or the toe may be used. Use the outside edge of the heel. Usually 2 quick pricks are necessary to obtain a steady flow of blood. And when using the toe, the outside edge is again less sensitive. Use the same procedure as the finger stick, but it is only applicable for infants below 6 months. Okay? But we're not infants, so we're going to utilize the fingers of our hand. But I forgot one important thing. Kay murag i-summarize na kaya na siya ka-form. Before attempting to pierce the skin of your finger, ensure that your hand should have adequate circulation. How do we ensure that an adequate circulation on our hand? You have to massage first. Massage your hand so that it would warm, because an area of the skin where it is cool is considered as having a decreased circulation. So we have to increase circulation to our fingers. How? It's by massaging. Massaging the hand. And then, during the act of collection, and then we place the capillary tube closely adjacent to the blood drop. Do not excessively massage the finger. Okay, you really wanted na the entire capillary tube, not the entire, but almost all, almost the entire capillary tube is filled with blood. So please, give space around mga 20% of the capillary tube with air so that you can invert the tube later on. And then also, do not excessively massage the finger because it again introduces tissue fluid to the blood drops. Okay? So just a gentle reminder. Gently massage the hand of your subject in order to increase circulation. And then once you're already in the act of collecting blood, do not excessively massage the finger where you the finger of your subject in order to avoid introduction of the tissue fluid. Is that clear? Okay. So here's a graphic illustration of the act of finger puncture. Okay. A few drops of blood taken from the finger to our heel are enough for certain laboratory tests used in the manual, such as white blood cell count, WBC differential count, hemoglobin determination, and detection of blood parasites. Example of blood parasites would be your Plasmodium falciparum in malaria, and even your mga filariasis. I would recommend na prepare. You should be able to fill up 2 capillary tubes with the blood of your subjects in the hematocrit termination and also in the RBC. Why? Para naamoy back up. Because what if yung mga errors later on in the steps and you need to, wala na mo yung blood sample. So you need to obtain blood from your groupmate. So maybe maluoy mo sa inyong groupmate na mapurot na ang tanan fingers sa iyang dili yun, kay third and fourth na ba, dili allowed ang thumb, kay it's thickened. So, kung wala na yung blood na buus out from his or her finger, maybe you have to choose another group member to provide the blood. Okay? So, I would recommend maybe at least 2 capillary tubes per test sa hematocrit and the RBC counting. Because the hemoglobin, you will just obtain the value mathematically. Okay? So the hematocrit is a commonly performed investigation in hematological laboratories for evaluation of patients with anemia. So hematocrit or packed cell volume is the volume occupied by the red cells after the blood is centrifuged at high speed. So the hematocrit is the red portion in the capillary tube after sufficient centrifugation. There are 3 methods for the estimation of hematocrit: macrohematocrit, microhematocrit, and the automated method. The automated method is done using the sophisticated hematology analyzers in our standard clinical laboratory. So we don't have this, that's why we're going to perform only the microhematocrit method. So the hematocrit is the ratio of the volume of erythrocytes to that of the whole blood. And it reflects the concentration of red cells, not the total red cell mass. Because the total red cell mass is calculated, or the value of the red cell mass is associated with the RBC counts. Okay? The RBC count. So, when handling the capillary tube, you have to perform at least 8 inversions. So the capillary tube is described as a 10 to 14 times 25 millimeter tube. That's the dimension of the capillary tube, filled with 5 ml of blood and an air bubble around 20%. So the air bubble is necessary in order for adequate mixing of the blood inside the capillary tube. So hence, the length of the blood column inside the capillary tube should be around 2/3 to 3/4 of the entire length of the tube. We do not fill up the capillary tube to its brim, meaning halpapuno na yun ang capillary tube with blood. Leave around 20% or 2/3 to 3/4 of the entire length is made up of the RBC, okay? Or blood rather, blood. If the tube has been standing, this refers now to the blood tubes, okay? The blood tubes with a colored stopper. For those who are familiar with the blood tube. So the blood tube in the hematology section is colored purple or lavender. Okay, but we don't have that here. So, but if the tube is available, you need to do around 60 inversions of the tube or 2 minutes in a mechanical rotator. But since we are using the capillary tube, at least 8 inversions in order to mix the blood sample of your subject with the anticoagulants lining the interior of the capillary tube. Okay, so after centrifugation, there will be gross inspection. So the blood inside the capillary tube should separate into 3 components: the red part, the clear part, and the light yellow. Okay, the red part is the hematocrit, okay, made up purely of red cells. The central or the middle portion is what we call as the buffy coat. The buffy coat is a clear layer composed only of your WBCs and the platelets, while the large area bit of the yellow, having a yellow color, this comprises the plasma, okay, of the blood. So when there is a change in the color of the plasma, like for example, it will turn orange or green, it will indicate that there is increased bilirubin in the plasma. Maybe the patient is undergoing hemolysis. Okay? And then if it's pink or red plasma, it is due to hemoglobinemia. There is increased proportion of hemoglobin in the, or there's leakage of the hemoglobin into the plasma. That's why it will turn pink or red. Again, this is also consistent with hemolytic reaction. If the color of the plasma is cloudy or milky, it will be due to abnormal hyperglobulinemias or cryoglobulinemia. These are just abnormal protein disorders. Okay? So the color of your plasma should be straw colored. Okay, straw. You know what's straw? It appears light yellow, pale yellow. Okay, but if the color is milky, maybe the patient has a lipid disorder. And then if it's intensely yellow or Orange, maybe the patient has icterus or a liver disorder. Okay. The hemolysis colored reddish or dark pink. So the microhematocrit method utilizes the capillary tube, about 7 centimeters long, with a uniform bore of about 1 millimeter. So the bore refers to the diameter of the tube. Now, the capillary tube is not free of an anticoagulant. The anticoagulant in the capillary tube, lining the capillary tube, is the heparin. How do we know? But not all capillary tubes are lined by an anticoagulant. One clue here is that if the capillary tube is red tip, okay, it would indicate that the anticoagulant is heparin. Okay, the capillary tube, okay, in this container is filled up with is blue tip. Now the blue tip capillary tube is only used if we will be utilizing venous blood, okay, not capillary blood. Okay, so maybe it is used to obtain blood from a blood tube rather than from the direct from the patient's skin. Okay. But there are also some tubes that it lacks any color tip. If it lacks a color tip, meaning it does not have any anticoagulant inside it. So the color of the color at one end of the capillary tube indicates that it is covered by an anticoagulant, hence blood won't easily clot inside it. Okay. And also the microhematocrit method also needs the presence of a reading device, which we term as the microhematocrit reader. And we have that upstairs. So the capillary tube is filled at least 5 centimeters or 2/3 or 3/4 full, and the empty end is sealed with a modeling clay or a sealing clay. The end or the tip of the capillary tube where you're going to seal is the one that lacks the red color. Okay, the red tip end is where blood enters the tube. So you just try to touch the red tip end with the blood tube, the red tip end with the blood drop of your subject, and blood will easily enter now the tube. And the process is what we term as the capillary action. So the capillary action is the one responsible for the instant entry of blood inside the capillary tube once it touches it. So the filled tube is placed in the radial grooves of the microhematocrit centrifuge head with the sealed end away from the center. Always remember the proper placement of the tube inside the microhematocrit centrifuge. The sealed end should be placed away from the center of the centrifuge. Okay, not the other way around. Centrifugation for 5 minutes at 10,000 to 12,000 G, or unless the hematocrit is 50%, an additional 5 minutes of centrifugation. So it is only applicable for patients suspected to be harboring polycythemia. So the length of the blood column, including the plasma, and of the red cell column are measured in millimeters. So the interpretation of the results for males, 0.41 to 0.51. For female, it is lower from 0.36 to 0.45. The variation in the values between the sexes is often attributed to the effects of the male androgen hormones. That's why males have a higher hematocrit, RBC, and hemoglobin value compared to um, females. There are also errors in microhematocrit method, so one should be worried or be aware of this lapses. Error in centrifugation, wherein there's inadequate duration and speed of centrifugation. Hence, the value now that we obtain would be erroneous. So, upstairs, kindly seek the assistance of our laboratory technician prior to operating the microhematocrit centrifuge in order to avoid what? Any accidents. Okay? Upstairs. And then errors inherent in the sample, like posture of the subject, muscular activity, and prolonged tourniquet stasis. Okay? But the stasis is only applicable sa katong venous blood extraction. Ang ato lang i-avoid in the capillary method is excessive squeezing of the finger and improper introduction of tissue juices into our blood sample. Posture is also one factor that will cause errors because when the patient or when the subject is in a supine position, there would be increased plasma volume that will be introduced into the blood. Hence, the hematocrit of the patient might decrease by as much as 10%. Okay, so posture, especially in a supine position, can also interfere with the accurate result of the hematocrit of the hematocrit. Other errors is failure to mix the blood adequately before sampling. So how many inversions is needed? At least 8 inversions. Improper reading of the levels of cells and plasma, especially when using now the microhematocrit centrifuge. So kindly seek help in recording the hematocrit value using that particular reading device. Inclusion of the Buffy code as part of the erythrocyte volume is also one cause for error. So here is a actual image of the microhematocrit centrifuge. So there are groups inside this laboratory apparatus. So just place your capillary tube inside with the sealed end away from the center of this circular chamber. Okay? And then, after centrifugation, there's a separation of the components. If the RBC counts, if the hematocrit column is shorter than usual, maybe the patient has anemia. So there's a decreased hematocrit value. But if the red cell column is larger in area, then maybe the patient is suffering from polycythemia vera or having elevated hematocrit value. Okay? So high hematocrit or packed cell volume is found in situations like a patient is suffering from polycythemia vera, intake of anabolic steroids, especially among athletes. Okay? Dehydration of the patient, maybe constant vomiting or several episodes of diarrhea, hence leading to dehydration. It can contribute to it can lead to a high hematocrit value. Persons who suffered burns, chronic smokers, people who live in high altitude places, and then of course, episodes of diarrhea. So these are some of the clinical or practical examples or situations when the hematocrit value is elevated or increased. Meanwhile, if the hematocrit value is decreased, it is attributed often to anemia, hemolytic reactions, nutritional deficiencies, bleeding, and pregnancy. Notice that the items after anemia are considered as etiologies of the underlying cause of anemia. Okay? So anemia is defined as the decrease in the red cell mass to adequately deliver oxygen to the peripheral tissues. Hence, the patient will now show signs of anemia, like pallor, easy fatigability, etc. To establish the presence of anemia in the laboratory, we can use the hemoglobin, hematocrit or packed cell volume, and the red cell count. So this is the triad of laboratory tests to ascertain whether the patient is anemic. Because it is easiest to measure, hemoglobin is the most frequently used parameter to detect anemia. Though the parameters can be measured manually, it is best to measure them on an automated analyzer. Okay? So, our physicians in the hospital rely most often on the automated methods to provide CBC because it is more accurate and precise and it is much efficient compared to the manual method. But when you are working in the rural areas where electricity is not very stable, so it's also wise to be familiar with the manual method of measuring these three parameters. So the hematocrit is usually 3 times the hemoglobin value. That is the rule of 3. Okay? So this how we're going to obtain our hemoglobin value. We just divide the hematocrit divided by 3. But the rule of 3 is not absolute. It is not applicable to all situations. I think it's only applicable if the patient's red cells is normal. So mga normocytic, normochromic. But kung nasa hemolytic episode of hemolysis, we should not apply the rule of 3. There's also another rule, the rule of 9. What is the rule of 9? The rule of 9 is just we multiply the RBC count times 9 and we obtain now the hematocrit value. Okay? So this is just for your fancy, the manual method of measuring hemoglobin using the Sally method. So the principle here is the blood is diluted with an acid solution to acid hematine, and the test solution is matched against a color glass reference. So this particular apparatus here. But the problem with this method is that it is an accurate way to estimate hemoglobin because not all hemoglobin is converted into acid hematine. So the color changes are not great, and the brown color of the standard is not a true match for acid hematine. The results, therefore, are very subjective and subjective to each individual doing the test. So this is just for the sake lang of your curiosity. Okay, so there's a manual method of measuring hemoglobin. This is the Sally method, but we're not going to perform this upstairs because we don't have the said apparatus. There's also another way of estimating hemoglobin. That is the copper sulfate method. So this method is based on a specific gravity. Okay, the weight now of the blood drop or specific gravity. A drop of blood is allowed to fall into a solution, a copper sulfate solution, encased in a sac, which prevents only a change in a specific gravity for about 15 seconds. If the blood drop has an adequate specific gravity, it would sink within 15 seconds. If not, the drop will hesitate, will remain suspended, or will rise back to the surface of the solution in 15 seconds. So this is not a quantitative test and will show only that the hemoglobin value is equal or below the above acceptable limits. So this is just an estimation lang. If the blood drop sinks to the bottom of the solution after 15 seconds, therefore, that patient has an adequate hemoglobin value. I think the last time I saw someone performing this was during an MBT or a bloodletting activity. Okay? But it is not, but it's only an estimation. We do not give a numerical value. Okay? After performing numerical value of hemoglobin after performing the copper sulfate method. So let's proceed to the manual RBC count. It is the number of erythrocytes per microliter of blood. Notice that the ranges of the manual RBC count in millions, in millions, varies between the sexes and also between the in the age of the patient. The RBC count of a healthy human being will decrease as the person ages. So newborns do have a higher RBC count compared to an adult individual. Okay? And between males and female, males have a higher RBC count. Again, this is due to the effects of the androgen hormone or testosterone. Okay. So erythrocyte count increases in case of polycythemia, which is considered as pathologic. Okay, pathologic polycythemia, and decreased in anemia. So in order to facilitate RBC counts, a specified volume of blood is diluted with a specified volume of isotonic fluid. Why isotonic fluid? Because it will ensure that the shape of the RBC is maintained. Okay? The biconcave disc shape of the RBC is maintained in isotonic fluid. So the criteria for choosing a adequate or a satisfactory red cell diluting fluid or diluent must be, it should have the following properties: anticoagulant, anti-hemolytic, anti-aggregation, anti-Rollo formation, and it preserves the biconcave disc shape of the erythrocyte. Are you familiar with Rollo? So Rollo is the stacking formation of the RBC in its natural state. Okay. Like a stack of coins or a pile of coins. So the examples of diluting fluid are as follows: isotonic, saline, and high solution. But in here, isotonic saline is more easy to obtain, hence we choose this diluent. It is composed, or its composition is 0.85% sodium chloride in distilled water. The reason behind for selecting isotonic saline is it maintains, again, the normal disc shape of the RBC and it prevents auto-agglutination. But some fun fact about isotonic saline is that it will cause slight granation of the RBC, but it won't really affect overall the RBC count, but will just bring about slight puckering or carnation of the RBC. And then another apparatus that we need to utilize in the RBC count is the Neubauer hemacytometer. So if this is the what do you call this? The lancet, and this is the capillary tubes, which is red tip. Okay, this lined by heparin. This is the this is the sealing clay. Okay, the sealing clay. Kapag yung end na walay red, okay, dito mo mag-seal. And then we have this improved Neubauer hemacytometer. Okay, this one. Okay, so the improved Neubauer hemacytometer has two chambers. Okay, the chambers refers to the shiny platform. Okay, this is where you're going to introduce or charge the blood solution later. Okay. So, the Neubauer hemacytometer is a glass apparatus, a precision-made slide for performing manual cell counts with the aid of a microscope. the rationale for using the Neubauer hemocytometer is when automated cell counters and hematology analyzers are unavailable, especially in far-flung areas or those who live in GIDA, geographically isolated areas. And then when blood cell counts are extremely low, like severe anemia, then to get a cell count of bloody fluids like spinal fluid, CSF, synovial fluid, and even the semen of male patients, we obtain the sperm count using the Neubauer hemocytometer. Okay. So the numbers written on the chamber mean that the space between the chamber and the cover slip, so the chamber is the shiny platform, is 0.100 millimeter, and that's the smallest square on the grid as an area of 0.0025 square millimeter. So they're just mga numerical values found on the surface of the glass apparatus. Okay, but before before introducing or charging the Neubauer chamber, ensure that the surface of those chambers are clean, as well as a cover slip with 70% alcohol, either isopropyl alcohol or your ethyl alcohol. Okay, so this procedure would require the following scientific instruments. You have the Neubauer slide. There's a cover slip lined on top of the chambers. Then you have the necessary pipettes, red cell pipette or the white cell pipette if we're going to perform the WBC count. But since we're going to perform the RBC counting, we use the red cell pipette, and there are differences between these two blood pipettes. So, the improved Neubauer hemocytometer is a thick, specially made glass slide, and in the center of the slide there's an H-shaped groove. I think it is easy to locate the H-shaped groove in this apparatus. So the two glass platform makes up the upper and lower part of the letter H. Okay, and then there is like a groove at the central part of the groove separating the upper and the lower chambers. That's why it resembles letter H. Okay, and the red cell pipette is composed of a stem and a mixing chamber with a red bead. Its function is to mix the blood with the diluting fluid. Okay, and then here is a schematic illustration distinguishing the red cell pipette and the white cell or WBC pipette. Here are the general parts of the pipette. We have the calibrated stem, we have the bulb, and then the short stem or the stem when we're referring to WBC pipette. Inside the bulb, there is a bead inside. The color of the bead is helpful in distinguishing the two pipettes. Aside from the bead, you also take notice of the numbers, the markings on the sides of the pipette. Because for RBC it is 0. For RBC pipette it is marked 101. For WBC it is marked 11. Okay, in the stem part of the capillary tube. So the stem is this area here. This one. The stem part is where you're going to insert the rubber tubing. Because natay group, I think, last time na ki-insert ang rubber tubing where ang opening for the blood to enter the pipette. So nasayop pag-insert sa rubber tubing. So the rubber tubing should be inserted at the stem na naay mark na 101 for RBC and 11 for WBC. Okay, is that clear? So these are the key differences between the RBC pipette and WBC pipette. It has graduations up to Mark 101 for the RBC and Mark 11 for WBC. The size of the bulb is larger for the RBC pipettes, and it is the opposite for the WBC pipette. But insofar as the size of the lumen is concerned, it is smaller for the RBC pipettes and larger for the WBC pipette. Okay? So these are the very crucial distinguishing characteristics between the RBC pipettes and the WBC pipettes. So, I think it's a reiteration, no? So, with a sterile disposable lancet, do a small prick on the fingertip. When a drop of reasonable size has collected, hold the red blood cell pipette slightly tilted from the vertical position. Apply a tip to the drop and aspirate blood to the mark 0.5. We have to take advantage of the rules of physics, okay? Because if the interaction of the blood drop and the apparatus is in a horizontal position, I think you will encounter some difficulty for a faster entry of blood inside the capillary, inside the pipette. So I would suggest maybe to place it in a somewhat close to horizontal alignment in order for a more faster entry of blood inside the lumen of the pipette. Okay? Wipe off any blood adhering to the outer side. If the blood gets beyond 0.5 mark, tap the tip gently till the blood is exactly at the mark. But how do we, never allow the blood to clot inside the pipette. If the blood clots in the pipette, blow the sample out and clean the pipette and begin all over again. Okay? Aspirate diluting solution to the 101 mark, thus making it was 200 dilution of blood. How do we achieve this? Utilize the syringe included. Do not mouth pipetting. Okay? Do not use your mouth to draw in the diluting solution to the 101 mark. Hold the pipette horizontally and hold it with both hands between finger and the thumb. Blow out a quarter of the center to remove the pure diluting fluid in the stem. Prepare the counting chamber and cover it with a cover slip. Hold the pipette and touch it tip gently on the surface of the counting platform where it projects beyond the cover slip, and a small amount of solution will be drawn under the cover slip. Just ensure that the blood solution that will introduce into the chamber is just enough. Do not allow the blood solution to spill into the moat. Kaning moat is the groove on the side of the chamber. Okay? Do not allow it, because if the blood solution will spill over into that area, you have to repeat the process again. Repeat the act of charging. Place the Neubauer on the stage of the microscope and allow 2 minutes for the cells to settle. But in your lab guide, 3 to 5 minutes. So either 2 minutes, 3 to 5 minutes, that would be okay with me. And then scan the counting area with a 10x objective lens. So you're now ready to count your RBC. So get your microscopes and then scan first using the low power objective. You have to locate first a particular area in the Neubauer grid where you're going to count your RBC. So scan using the low power objective, and using the high power objective, include all cells lying on the upper and left lines of any square and omit the cells on the lower and right-hand lines. So the act of counting the RBCs in the Neubauer grid will be in a serpentine fashion. Left to right, then right to left. That is the preferred technique in counting the RBC. Left to right and right to left. But in case the cells would touch the triple lines, okay? If it's in the right and the lower triple line, exclude them. But if it touches the upper and the left triple lines, include them in the counting. Okay? But all the cells inside must be counted in a left to right and right to left fashion or serpentine. So this is the low power view of the counting grid. Just select the extreme upper left, extreme upper right, extreme lower left, extreme lower right, and at the center square. So it only shows 5 small squares. Extreme right, extreme upper right, extreme upper left, extreme lower right, extreme lower left, and the center. So it's like letter Z ang counting. So we have to locate first before counting the cells. Okay? And then, after counting, you need to count all the cells. So, pwede mo mag-square number 1, square number 2, square number 3, number 4, number 5. Add them. That's for chamber number 1. Okay? And then, perform it again using chamber number 2. So, square 1, 2, 3, 4, 5. Get the sum of the chamber 1, chamber 2, and then average them. That is the value for letter N. Hence, the formula for the total RBC count is N times dilution factor times volume correction factor. The dilution factor is 200. And the more easier way of remembering the formula is N times 200 times 50, or simpler pag siya, N times 10,000. Okay? So, source of error, false high count is seen when there's improper mixing, uneven distribution of cells, error in pipetting, error in calculation, blood taken from area of hemoconcentration, especially if there is prolonged tourniquet stasis. Yeast, dirt, and leukocyte are counted as RBC. So ensure that your Neubauer hemocytometer is clean. Okay? As well as the cover slip. Dapat clean sa siya. False low count is seen in cases where blood is diluted with tissue fluid. So excessive squeezing of the finger is the culprit for this. Undue delay in counting of cells. So, sama ni siya. You have to allow only 2 to 5 minutes for the cells to settle. And then quickly count the cells. Okay? Under the microscope. Clumping of cells in autoimmune hemolytic anemia, uneven distribution of cells, faulty technique of counting, and improperly standardized counting chamber. Okay? So therefore, the Neubauer hemocytometer is defective. Okay? So make certain that the pipettes, hemocytometer, and cover glass are free from dirt, lint, and dried blood. Ensure that the diluting fluid is free from blood and other contamination. So ensure that the materials that you're going to use is clean. Okay? Kung hugaw ganin siya, replace them. And also, please remember to properly discard your used materials in a proper receptacle. Ayaw ka ipaglabay-labay bisa kasa ang katong mga lancets. There's a container there upstairs for the proper disposal of the said materials. RBC takes longer to perform than WBC because the larger number of cells. Therefore, proceed as quickly as possible once the cells have settled. Drying of the dilution in the counting chamber causes inaccuracies in the final cell count. The range of error for manual RBC is generally about 10 to 20%. Ang range of error. What is the range of error for the hematocrit? According to your manual. Nagbasa mo sila mga manual? Do you have your manuals with you? Your hematocrit is around 4% plus or minus a hematocrit. Okay? So any question before we proceed upstairs? Okay. So do not hesitate to ask any question sa